with a conversation about what hopefully you refreshed your memory on yesterday as you wrote for me how to find the derivative of a function. What's the very first step in the process of finding a derivative? That's right. Ask yourself, what is this thing? So by that, what are possible answers of what is this thing? A quotient, product, sum, constant multiple, yada, 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 right? And what does that do for you? Tells you what rule to use, okay? Well, then we encountered things that we had not found rules for prior when we learned our most recent lesson on the chain rule, yes? When do I use the chain rule? When I have a composite function. How do I recognize a composite function? That's right, we have a function inside a function. So I'm looking at a function that's familiar to me, but inside it I find something more than just x, yes? Makes it a composite? All right, well, today you're going to learn implicit differentiation, which is the process that we use to differentiate when the x's, well, let me rephrase that. I was going to leave the s off. The x's and y's are cohabitating. Now, obviously, cohabitating is not an official math word, but what does cohabit mean? They live together, yes? Okay? So this is what implicit differentiation is for, all right? So there is a process, and I'm not writing the term implicit differentiation because that's literally all this lesson is about. The process, step 1, is differentiate, and I'm going to abbreviate that to DIFF, differentiate both sides with respect to x. I'm going to tell you that as we write these steps of this process, it's going to sound really simple, but as with many things in calculus, the things that seem really simple on their face become much more complex when you attempt to do them on your own. All right? Step 2 is to collect the dy dx terms on one side Now, typically, you will probably choose to use the left side, but there's no rule about whether you do it on the left or the right. And then once you've collected all your dy dx terms on one side, your next step is to factor out dy dx. And then the final step in the process is solve for dy dx. And if you didn't need examples, we'd be finished. That's pretty much the entire lesson. Ready for some examples?
Can you go back to the...
Can y'all write faster? You're going to be screwed in college.
So is this going to look like bullets on our homework again? Like step 1, do that, and step 2, do that?
Yep. Well, no, it's really going to look more like you're solving an equation and the steps in solving an equation.
It's 20. It's Friday.
Yes, it is. And this is the best Friday I've had in about 9 weeks. Because I uploaded it last night. And while you're in the mood to applaud me, I got my grade for the first course last night.
99.
100. So all of my, dear God, I think I'm going to die before this is finished, was worth it. So everybody got all these steps now, all big 4 of them? Okay. All right. And you may or may not look back at the steps. I was the kind of kid that would write the steps down, never look back at them, because once you showed me the examples, I had it. So hopefully that'll happen for you. I'm sorry. Yes, I was that kid. I taught my Algebra 2 class. Get off my back. That's how I knew I could be a math teacher. All right. 2 in your book says x cubed plus y cubed equals 180. No, sorry. Delirium. 18xy. How about that? I was going to say 180. Did they really put 180 as a coefficient? There it is. X cubed plus y cubed equals 18xy. Do you see what I mean by the cohabitation of the x and y? They are together all over the place. And you might recall problems similar to this, not quite this ugly, from pre-cal when you were finding inverses. And your first step was to try to isolate the y. And then you're like, oh, wait, how do I do that? And you would have a similar reaction to trying to isolate y in these problems. Now, if it's obvious that you can isolate y, you can isolate y first. There's nothing that says you can't. But typically, the process of implicit differentiation is by design for problems like this where you just don't want to do that. All right, so what's step one? So here's what I would like to see on your paper. And yes, when I do examples on the board, that is an indication of what I'd like to see on your problems when you do them. So put parentheses around the left, and in front of it write d dx. What does that mean I'm about to do? I'm about to take the derivative with respect to x. Then on the other side, and you have to put the d dx on the left. If you put it on the right, you're going to look like crazy. And then you can tell them your calculus teacher drove you there. So, but see, that's kind of mushed, but at least it shows where the next thing is about to come from, okay? Now, when you are doing implicit differentiation, you will learn to appreciate terms like x cubed. Why might you appreciate x cubed? Because we know its derivative, 3x squared, right? That has not changed. So when you encounter a term that only has x in it, you approach it just like you did before, okay? The change comes when you get to terms like the next one. The first step in taking the derivative of a term that does not contain the variable that you are differentiating with respect to, and what variable is that in this case? X. So since I have a y term, I start by taking its derivative as if I'm taking its derivative with respect to its variable. So I take the derivative of y cubed as if I am taking the derivative with respect to y. So that's the first piece of my answer. But this is like the chain rule. Because y is what? Y is not x. That's good stuff, guys. All right. Y equals, from Algebra 1 days, f of x, right? So y is a function of x, yes? So I could think of y as the outside function, which would make x the inside function, right? So that means I multiply by the derivative of y, and that's where the dy dx comes from. So that's the derivative of the inside part. The inside part is y.
Wait, can you explain that one more?
Okay,
Wait, the inside part's why?
let me do this. I'm going to do this over again because I debated, and I've never taught it this way, but I was thinking about it last night, and I thought maybe I would try it this way this time. All right, so we're taking the derivative with respect to x, yes. Don't erase yours, but watch what I'm about to do. All right, x is explicitly a function of x, yes? So I don't need to say anything about it, right? Okay, but so this is, I could rewrite the function as x cubed plus y of x cubed equals 18x y of x. Does that make sense? Because now I'm making it explicit what I'm doing. All right? So then, when I write the next step, hopefully this will clear it up for you. So the first term is 3x squared. And then, as I said, when you get to a y term, you take the derivative of it with respect to its own variable. Okay? This is like those problems you've done on your 4-1 assignment. The ones like I went over yesterday, where it tells you u is this and f is this. And so then f was expressed in terms of u, and then g was expressed in terms of x, and it said u is g of x. This is sort of that same idea. All right? So I start out with 3y squared, but then I have to multiply by the derivative of y. But I don't know what that is, do I? Because y is just y. So all I can write is dy dx. Okay? Equals, and now I have 18 as a constant multiple, so I'm going to go ahead and write that before I even look to see what kind of animal it's attached to. And what is xy? A product. So those questions are still in your head. They still have to come into play. All right? So this is a product, which means I'm going to be applying the product rule. If I keep the y, what do I have to do with x? Its derivative, which is 1. Yes? And then plus? Keep the x, dy dx. So we have done step 1, which is to take the derivative of both sides with respect to x, yes? What's step 2? Alright, so let's get our dy dx terms on the left, and anything that's not dy dx, we're going to toss it to the other side, right? Okay, so we're going to move 3x squared. So we're going to start on the left side with 3y squared dy dx. You with me, Neil?
Yes, ma'am.
Okay. And then on the right side, we're going to, instead of writing that step out so you OCD people would have another step here, I have 18y plus 18x dy dx, right? So the 18, which one comes over?
18x.
Right, so since it's plussed on that side, when I bring it over, it's going to be minused over here. So this is 18x dy dx equals. So that's all my dy dx terms, right? Everybody that's not a dy dx term belongs on the right. And my first one is the one that was already there, which is 18y. So what comes after that? Minus 3x squared. So far, so good. All right. What's the next step? Factor out dy dx. And when I do, I am left with 3y squared minus 18x equals 18y minus 3x squared. No. All right. And then to get dy dx by itself, what do I have to do? I have to divide by that binomial. Now, some of you will show that on your paper, but you don't have to. We're big boys and girls now. We can get past writing everything that goes through our head. So we say, well, dy dx is just going to be equal to the right side as my numerator. So 18y minus 3x squared divided by 3y squared minus 18x. And that is not my final answer, and you should see why.
You can take it out.
I can take a 3 out of both the top and the bottom. So this is 3 times 6y minus x squared over 3 times y squared minus 18x. I'm sorry, you're right, thank you. I am so brain dead that it's a wonder I'm still talking. 8y squared. And writing in this little tiny screen is also kind of weird. No, I want it to be 18. I have to stop talking while I fix my error so that I don't make it again. 6x. Got it right now? All right, obviously now the 3's cancel, and my final answer is dy dx equals 6y minus x squared over y squared minus 6x. And that, boys and girls, is my answer. Now, normally when we find our derivatives, so far up until today, they have been either constants or expressions with x in them, right? Which means that the derivative of a function expressed purely in x is going to be expressed purely in x, right? But when you have functions that look like this, your derivatives are typically going to depend on both x and y. So now to know the derivative at the point, so if I had to write a tangent line for this equation, or for this function, and for this relation, we won't call it a function because when x's and y's are cohabitating, it's a lot harder to tell at a glance. If I wanted to know what the equation of the tangent line would be at some point, now I've got to plug both the x and the y in to get it. Does that make sense? Okay? Are you scared yet? No? So you think it's pretty easy?
It's gonna get harder, though.
That was the one number 2.
Yeah.
Let's do number 12. Oh my gosh.
Wait, before we start, can I ask you a question?
Yes.
Okay. Like I used to think of whenever you took like the derivative y, like how you said like pretend like it's in respect to y, but
No, that is the chain rule. That is the chain rule. Whether you can accept that that's the chain rule or not depends on how you process the information I just gave you. Because y is a function of x, okay? And y depends on x. It is the dependent variable. X is the independent variable, right? So since y is a function of x, and I don't know what y is, to take its derivative, I must express the derivative of the y thing, which is what I see, which is why you do it just like you do when you're doing x. But then I must multiply that by the derivative of the inside. What's inside that function is y. Does that make sense?
Yes.
Okay. And for some of you, some of the details of this and the whys and all that sort of thing may not make perfect sense yet, and a lot of that has to do with how hard you've worked prior to today. But for those of you that it doesn't just make sense for, then what you need to do is just accept it, practice the process, and then hopefully at some point it'll click for you. All right, the directions here say find dy dx and the slope of the curve at the indicated point. Okay? So this is exact case of what I was just talking about. All right, so you can see it in action. All right, now, in a perfect world, you would be able to tell me exactly what we are looking at in this equation. X plus 2 the quantity squared plus y plus 3 the quantity squared equals 25. It's a circle centered at -2, -3 with radius 5.
Of course.
And that, well, it should be, of course, but we couldn't get the conics last year because we just couldn't get there, right? So this is a circle, and the more of this you know, the more it won't confuse you when you come up with, say, 2 answers or, you know, strange things happening and that sort of thing, all right? So here we go. 1, -7 is a point on this circle, and our job is to take this derivative, all right? And how do I know that this is, because this is another thing that you get lost in the way most high school math is taught. How do I know when I look at this equation that it's going to have to be implicit? You don't know what means? Implicit? That's what we're doing today. How do I know I'm going to have to use today's strategy on this problem? X and Y are together. And if you kind of stare at this for a minute and try to imagine what you would do if you wanted to isolate Y. Do you see the problem? Because the first thing you would do is move the x plus 2 squared over, so you'd have 25 minus that quantity squared. And then you would have to take the square root, and it would be plus or minus, and then outside that you have a minus 3. Okay? So this one you could isolate Y, but it wouldn't be pretty. All right? So we're going to take the derivative as it sits. So the derivative with respect to x on both sides being noted. All right? So how do I take the derivative of such a thing as x plus 2 squared? Think before you speak, please.
That's what the chain rule.
Yeah, I heard it over here somewhere. Is that you, Matthew? Oh, yay, Matthew. All right, so what is the derivative, the first piece of the derivative if I'm using the chain rule here? 2 x plus 2 to the 1, if you want to be emphatic, times 1. I would suggest you write that times 1, even if you had gotten to the point in the chain rule assignment where you weren't writing it. But since you're doing a new complex lesson that many students never master, I suggest you write all those little things for this lesson to kind of just, as you have to go back and error check, you'll know you didn't forget that, okay? And then the next one is going to be 2 y plus 3 to the 1. Very good, dy dx equals 0. So far, so good? All right, what's my next step? Okay, well, how many dy dx terms do I have on this one? 1, so that's going to be easy to collect, right? So I'm going to just move the other term to the other side. So I have 2, the quantity y plus 3 dy dx equals, and I would not distribute that 2. Resist that urge, because what will happen, even if I'm going to divide that off, is sometimes the 2 will cancel with something. So I don't want to distribute that in. All right. Not to mention the fact that we want to know other things about our derivative typically. All right, so that means I'm going to move the 2x term. So I'm going to do negative 2 because I subtracted it from both sides, right? So that's negative 2, x plus 2, and that's it, right? Okay. And so now what do I need to do? Solve for dy dx. So I divide both sides by 2, y plus 3. So I have negative 2, the quantity x plus 2, divided by 2, quantity y plus 3, and the 2's go away. And what I was alluding to, probably fairly incoherently a minute ago, is that when I have a derivative that looks like this, again, I ask you to keep considering what it is we most typically do first with our derivative once we find it. What do we usually want to know about our derivative?
Where it's 0.
Where it's 0, where it's undefined. Yes?
Alright, this would seem kind of stupid, but how do you choose which one you put on the top? Like on the last step you just did?
Okay, because what was I really doing? This is this thing multiplying dy dx. I want dy dx by itself. I divided this off of both sides. So that's how you know which one goes on the bottom.
When you only have one dy dx, you don't factor anything out.
Well, there's nothing. No, because you're just going to divide off whatever's multiplying it. Yeah, exactly. Yeah. But in this particular case, we have negative x plus 2 on the top, y plus 3 on the bottom. Where is this function, or I'm sorry, this derivative equal to 0? That is, where would this circle have a horizontal tangent?
2.
Negative 2, right? Because that would make the numerator 0, right? Because the fraction is 0 when the numerator is 0. Where would this function, okay, first of all, where would a circle have vertical tangents? On the sides, right? On the left and right sides, and the horizontals would be on the top and bottom of it, right? Okay, so that means I would have 2 horizontal tangents, right? Because one at the top, one at the bottom. And because you get 2 different results when you plug in negative 2, right? How about where is it undefined? So where are my verticals at negative 3? Does that make sense? Yeah, but what accounts for that is that negative sign. You're going to say that only counts for one of them, but that's what it is. So just throwing that in there. All right, so what do we want? We want this slope at negative 7, and I didn't need that. Yes? All right, so this is the proper notation, i.e., this is what Twitty expects to see on her tests. So you do the long bar that hangs down below the dx line, and you put sort of as a subscript almost the coordinates of the point, and then you put the equals to the right and above that point. Okay? Because this says what you are about to see is this derivative at this point. So we have negative 1 plus 2 in parentheses over y, I'm sorry, not y, negative 7 plus 3. So 1 plus 2 is 3. So the numerator is negative 3. Negative 7 plus 3 is negative 4. So our slope at this point is positive 3/4. Make sense?
Yeah.
Questions so far? Can't decide. I think we'll go ahead and jump down to number 38. Number 38 is y equals x over the square root of x squared plus 1. Your directions here are, and we'll jot this over to the side so you'll know how you knew to do this. Find dy dx and d2y over dx2. What does that mean we're going to have to do? We're going to have to find our first and second derivatives, yes? Okay. And how do we know this is an implicit differentiation problem besides the fact that we are in this section?
X and Y.
It's not. Are you disappointed, Becky? You fell right into my trap, didn't you? Yeah, it's too easy. Okay. So we're going to find our derivative here. And what will we do first? And one of the reasons I did this is I don't want you to fall into that monotonous zombie state you fall into when you do 25 problems that all follow the same pattern. Because if it doesn't have x's and y's mixed together, it's not really an implicit differentiation problem. All right, so on the left we get dy dx, obviously, equals. And now what? What are our choices here? Quotient or product? I am a giant proponent of the product rule. But you'll have to remember that the reason the authors included this, so we've rewritten x over the square root of x squared plus 1 as x times the quantity x squared plus 1 to the negative 1/2, yes? But this is where they're teaching you, and I'm using air quotes here for the benefit of anyone not looking or who's having to watch this as a video, the rational exponent rule, which is what we were already using yesterday. So again, I don't really know why they did that. All right, so we're going to use the product rule. Tell me what to write. Yes, it is. Negative 3/2. Yes, is my new exponent. Times 2x. And I'm going to erase my giant note that's in my way. Okay. Times 2x. Where are y'all getting the 2x? It is a composite, so we're using the chain rule. Plus
X squared plus 1 to the negative 1.
no 1, right? Because we're taking the derivative of the x because we kept the x on the first one. Yes?
Yeah.
Okay. So times x squared plus 1 to the negative 1/2. Beyond some obvious things, why do I know I'm not going to leave my answer in this format? Why do I know I'm not going to leave negative exponents in my answer? It came to you with a radical in it. So that is the form you should return it in. Okay? So what's going to happen on this first term? The 2 and the half take each other out, right? So we'll slash those. So 1/2 takes out the 2. So tell me what to write for my... Well, in fact, let me give you a hint. Because we're about to take the second derivative, there's a step here I would not normally write. And that is the cleaned up version with the negative exponents. Because the negative exponents is what I want to look at when I'm taking its derivative. You see what I'm saying? So I'm going to go ahead and write this as x squared times x squared plus 1, the quantity raised to the negative 3/2.
Yeah, negative x squared.
Yeah. X times x. Everybody up to speed? And it may well be me because I'm like the little toy soldier and I need to be wound up again, but that only will come with about 18 hours of sleep this weekend. All right, so everybody with me now? Plus x squared plus 1 to the negative 1/2, which I will write as our final answer. This is the answer box version. Negative x squared over... And this is sort of, it's going to seem contradictory, but this is how I'm going to do it. I'm going to put x squared plus 1 in parentheses and raised to the 3/2. Now, that sort of contradicts what I said about the fact that we have a radical, but the fact that this is a cubed radical allows me to do what I just did. Do you see what I'm saying? But I still want to write it as a rational thing. All right, plus 1 over the square root of x squared plus 1. What else can I do to this? That's all you got? You're just going to tell me that's we need a common denominator? All right, so what would my common denominator be? To the 3/2, right? Because it's the bigger exponent, all right? So what would I have to do to the other exponent to get what I want?
Multiply by a negative 1 exponent somehow.
Yeah, now it's at 1/2.
Mackie, Friday morning is a good time to remind you that alcohol kills brain cells.
That was last Friday.
Yeah, I know, but you've demonstrated that you have such habits, so I thought I would throw that out there. Okay, I'm guessing the silence in the room beyond the awkwardness that I brought up the dreaded last Friday events. And none of that will be happening because I'll be at the game tonight to stop you from your stupidity.
Yeah, I won't.
Except that I'll be in the I'll be at the ticket booth, which would sort of limit my superpower heroes. I mean, a hero power. So anyhow, so I'm waiting.
You would cube a number.
Okay, you would cube it, right? AKA,
Raise it to the third.
can we just cube the top and the bottom of things because we want to? No. So we're not going to cube the top and the bottom. We're going to. What is the same thing as cubing it?
Raising it to the third power.
How about multiplying it by x plus 1 cubed? Is that what we want?
Yeah.
No, it's not what we want. Oh my God, I'm trying to get y'all to use your logic and think about the exponent properties. What do you do when the bases are the same to get the new exponent?
Multiply by an x plus 1, just no exponent.
Why?
Because then your exponents will add. And then
Thank you. That's all I wanted. And y'all are all like, we'll just cube the top and the bottom. No, we won't. All right, so that means that we will be multiplying the top and the bottom by, and I'm going to write this. I wouldn't actually write it if I were doing the problem, but this is to emphasize what just happened since you obviously need some refreshment on what it is to apply the exponent properties. So that my final answer is negative x squared, or not quite my final answer, plus x squared plus 1 all over. Don't strain your brains here, kids.
X squared plus 1 raised to the 3/2.
To the 3/2.
those x squareds are going to cancel.
Yes, they are, Mackie. Don't think that redeems you from that earlier comment. 1 over x squared plus 1 to the 3/2.
About that negative sign.
What negative sign?
X squared.
It was attached to the x squared that went away.
Oh, God.
He gets a point, he takes it back. Okay, now I want you to tell me why all that, what you probably think of as tedious algebra, was worth it. For 2 reasons. I'm about to take the second derivative, and I'd much rather take the second derivative of what I just found than any of those previous steps, yes? How about I take you back up to the orange version and say take the second derivative of that? Because then you've got a product
Now all we have to do is go
plus another term, right? Which is, and they're both got composites in them, right? And then I could do this green version, same problem. You see what I'm saying? So that's the power of doing the algebra to the problem. Not to mention the fact that even if I wasn't finding the second derivative, what else might I be doing with something like this? Finding where it's equal to 0, finding where it's undefined. Talk to me about both of those possibilities.
Speak to me.
God, Marty, y'all kill me. I'm like, talk to me, and then I hear, I really wish I had, and one of these days I'm going to find me a little device that has nothing but crickets stored on it, and I'm going to be able to like push the button without you telling that I'm doing it, and you're going to hear crickets when y'all do that. I bought you some time.
You can get an app to do that.
Or like, what do you mean, like, tell me, like, about this, like?
Oh, sweet heavens. What did I say before that? What might we want to do with this first derivative? Find out where it is 0 or undefined. When is this 0? Where are the horizontal tangents for this function?
-1. Nope, there's none. There are none.
Why not, Mackie?
I don't know.
Because it's squared.
No x equals 1 and equals 0 gonna give you 0.
You can't have a negative with the square.
Thank you, Zach. Let me say louder what Zach said. Because the numerator is 1. When is a rational thing 0? When the numerator is 0. When is 1 0? Never. How many horizontal tangents do I have? None. Thank you. All right. Now, the other question you were trying to answer is where does this relation have a vertical tangent?
Nowhere.
Why?
Where?
It's because it's x squared, because x squared plus 1 is never 0, right? Okay. All right, so now we're going to do our second derivative, and that was our first derivative, yes? What a slugfest that was.
Friday.
Oh my gosh. Hey, if I'm functioning, y'all should be. Don't say it, Matthew. Well, you apparently don't remember the day that, had everybody not been lined up in my way, I probably would have been over there getting peeled off of you by your classmates. Okay, so what do I want to do if I'm going to take the derivative of this thing down here in the corner? I want to think of it as to the negative 3/2, because this becomes a stupid easy second derivative, doesn't it? Because what is this now that I'm about to apply? Nothing but the chain rule, right? Okay, so tell me what to write.
I have a question. Why did we move it to the top?
Because I certainly don't want to apply the quotient rule to that.
I thought you didn't have to apply the quotient rule if there wasn't an x in the top.
You don't, because you rewrite it like we just rewrote it.
But even if you were to take just the root would be like you could just take the bottom. You know what I'm saying? Okay.
Y'all try that and see how it works for you, okay?
Alright.
All right, so then to write this more like the original form.
You only got 2x.
Oh, my bad. I'm sorry, I got sidetracked by that question. I was like, sometimes I think y'all are brilliant, and then you erase my thoughts by saying things that I don't understand. All right, so this is negative 3 times 2x in my numerator over 2 times x squared. You can cancel it there, or you can cancel it here. All right. I'm just working with people who don't seem to know how to sort things back out after they've done things like what we've just done to them. All right. So this is to the 5/2, yes. So the 2's go away and leave me with negative 3x over x squared plus 1 to the 5/2 in the denominator. Make sense? So where is this second derivative? Which my second derivative would represent what in terms of particle motion? The slope of the slope, which would be acceleration, right? My first derivative would be velocity. So what does that tell me about if this was a particle motion problem and we just found that first derivative down there in the corner?
Direction.
No, I mean okay, what did we say about it a while ago? It's never 0. So if it's never 0, it's either always positive or always negative. And if the denominator has an even number the denominator of the exponent the exponent of the denominator, that's what I'm trying to say, it has a 2 in its denominator, right? The rational exponent. What does that tell you about that output? The denominator is always going to be positive for that reason, right? How about the numerator? Always positive. So this relation is always increasing because we're talking about the first derivative.
Okay.
This green one that we just found is the second derivative. Now where is it 0? At 0. So that means that we have a little bit of a difference here, don't we? But we still have a square root in the denominator, which makes the denominator always positive. So that means that this derivative is always, this second derivative is always what? Negative, and always slowing down, right? Because it's always negative. All right, and the particle would always be slowing down. Let's do one more. I wanted to kind of hit different parts of the assignment, but I'm going to back up to number 26 now as our grand finale. X squared cosine squared y. Gosh, I've just read the first term and Mackie's already grunting. All right, x squared cosine squared y minus sine y. Oh, you've got some backup singers now, Mackie.
We got the equal sign.
Equals 0. So I guess I need to attribute my fatigue to what mere mortals feel all the time. That just proved my point, thanks. The directions here say find the lines that are A tangent and B normal to the curve at the given point. What does that mean? Because y'all are such weenies. Let me tell you something. This is college fall break window we've come into. We had PC was on fall break last week. USC and Newberry, I know, are on fall break this week. Clemson's on fall break next week, I think. So there's this streak of fall breaks coming. So I get my round of visits. Alex Cook, y'all know Alex, right? Came in, grabbed me, hugged me, almost slung me in a circle, and said, "I miss you so much," and told me that at Newberry, the math class he's in, the homework is all on Alex, which is a software program. And he is failing kickball. Yes, he is failing. He is failing kickball. Well, because he signed up for it thinking it's kickball. What are we going to do? We're going to go play kickball every day. I can sign up for that and get 2 hours of college credit. And I said, okay, first mistake. If the class is worth 2 hours, it is not just kickball. You understand that? 3 hours is a legit college course. 1 hour is like basket weaving or square dancing. And 2 hours is somewhere in between. So on Mondays, they actually play kickball. But on the other days of class, they have to do things like write a fitness plan. So a little reality check there. Stacy Ginther came in to visit from USC and I was like, how do you like college? Love it. It's awesome. I've never worked so hard in my life or gotten by on so little sleep. And she said, I thought I knew. She said, you know what? This is the truth. She said, I would go back and slap the bleep out of my senior self because I thought I knew what tired was. I thought I knew what struggle was. But college redefines it for you, or you fail. So that's the most recent updates I've got from the college world. So y'all need to suck it up. You just think you know what it is. You're going to find out.
Clemson does their homework, like calculus homework. My friends in Clemson take calculus right now, and they have to type it in on like a computer. And if it's like slightly a space off, you get the whole question wrong.
Yeah, they have to do that for chemistry.
That's crazy. Like, I mean, if there's like a space between a plus sign and
Oh, well, I will just tell you, when you have those little moments, when you're at one of those schools that's making you do things like that, just understand how much work went into me making those study guides for pre-cal. Think of all the things I typed for math in that. Yeah. It's not easy being me. All right, so back to this problem. If I want the tangent and normal lines, what do I have to have? Which slope? The first one, aka dy dx. And how do I know what to do on this animal? X's and Y's are cohabitating means that implicit differentiation. Madison said that like it's a dirty word. It's implicit. Like I'm so disgusted at the thought. The derivative with respect to x of both sides. Why does that right side make me super duper happy? It's 0. So just writing that over there makes me feel good about it. If I can hang out through the left, I'm good. All right, so when I go to take the derivative of the left, the first thing I see is x squared cosine squared y, which is a product. Let me give you a giant piece of advice here. If you are going to do the product rule, the first thing you should put on your paper is parentheses, a parenthesis. Okay? To remind yourselves, this is my product. Again, you're going to do nasty problems. You're going to screw them up, and you're going to try to go back and figure out where you screwed up. And if you don't have the parentheses, say, okay, this is where I was doing the product rules, you're going to have to go back and rethink everything you did. Your notation will save you from that. All right, so tell me what to write. Okay, I heard 2x first, so that's what we're doing. So we took the derivative of x squared, so what's the next thing I write? Cosine squared y plus x squared. Nope. 2. Nope. Cosine y. Yeah, it's a composite, and the cosine y is your inside function. So that's to the 1 times. Ain't no way dy dx right there. Negative sine y. Now what? Dy dx, because now that's the inside part of the sine, right? Do y'all see what I mean about how quickly this can go bad for you? Okay, so that is where I put my end parenthesis, yes? Because that was the chain rule on the first term. The good news is we've done the ugly part. So minus and equals 0. That's happy news, right? So we're going to clean it up, and we're going to get 2x cosine squared y, and then we're going to put all this together. All right, so tell me what to write. Minus. Decide the sign first, and then the coefficient, and then go from there. Negative 2x squared cosine y sine y, yes? Dy dx equals 0. So my next step is to get dy dx by itself, yes?
Wait, did we forget? You forgot the.
Oh, I'm sorry, it's this view I'm in. I'm trying to not write so big. Yeah, my bad. I may not even have room to squeeze it in. All right, so I got that, minus cosine y dy dx. And then if there was more room, I'd write equals 0, so that goes at the end, yes? All right, so now I'm going to do what? Isolate my dy dx terms, and anything that's not dy dx, move it over. We'll stick to the habit of putting our dy dx terms on the left, so we'll leave the 2 dy dx terms on the left and get negative 2x.
Miss Jordan,
Yes,
instead of moving all to the left, could you move it all to the right to make it all like
you could, but some people, it just bothers them. And then minus cosine y dy dx. I don't care which side you move it to, as long as you get your algebra right. Oh my God, I just left off all that term. Oh, y'all can be critics, but that's the only time you can open your mouth. When I ask actual questions like what to write, y'all just sit there. So there's my first term. No, I'm not even supposed to write that. That's the wrong term. Cosine y, sine y, dy dx, minus cosine y, dy dx, equals, dang it, I still don't have room. And that should be 2x squared cosine, not x squared, cosine squared y. Yeah, because we subtracted it. All right, now what do we need to do? I'm going to zoom back in so I'm not writing so huge that I can't squeeze everything in. Factor out the dy dx. So dy dx comes first. Equals. Not equals. I'm not going to go that far. Some of you will get to the point where you don't write as many steps, and I'm okay with that as long as you don't screw up. All right, so dy dx gives me negative 2x squared cosine y sine y minus cosine y equals negative 2x cosine squared y. Yes? All right. So then my dy dx equals negative 2x cosine squared y over negative 2x squared cosine y sine y minus cosine y. I was gonna say, is anything jumping out at anyone?
Negative 2x equal to
What about the negative 2x?
1 over 2.
But can't like.
You cannot cancel the negative 2's because the negative 2 is not multiplying the other term. You can take a cosine out of each term. All right, and I'm not going to show that. I'm just going to write the result. So that would leave me negative 2x. If you can take it out of every term, you can take it out of every term. You can't take the negative 2 out because it's only in the leading term on the top and the bottom. All right, so negative 2 cosine y over negative 2x squared sine y minus 1. That's definitely better.
That's it.
That's my derivative. What was my job here?
At 0.
Do a tangent and normal line with the point 0 pi. Okay, so we have to plug 0 pi into our derivative. So y'all do that now. So when I screw that up, you can tell me. Since I can get you to tell me where I screwed up. Maybe that's what I need to do with my honors pre-calc class, because when I sit up here and go over stuff, they don't say anything.
Shouldn't it be 0?
So you're just going to assume that if the top is 0, the whole thing's 0? That's a bad plan. And you can't just look at it anyway because you got to show me. Showing off your proper notation you've learned. Or you've actually seen. I won't say you've learned it yet. All right, so then that the numerator is 0 because it's 0 times 1, yes? And then the denominator is 0 minus 1, which is 0 over negative 1, which is in fact 0. But if it were 0 over 0, that would be undefined, not 0. So don't just look at the numerator. Check your denominator. All right? So if my, and this is, what is this we just found? This is tangent what? This is my tangent slope, which means that my tangent line is horizontal. How do I write the equation of a horizontal line? Y equals pi. Got it? And that becomes a very important question because we also have to have the normal line, right? So this was my answer to A. And again, when I give you a big white space on paper, it's your job to denote where your work starts for one and stops for one and starts with the other. All right? So now I need to know my normal line, yes? And since the at this point, the tangent slope was 0, what does that imply about my normal slope? Undefined. What kind of lines have undefined slope? Vertical, which means that my B answer, aka the y-axis. Got it? That's it. You actually have 25 minutes, unless your name is Becca. And then, and so you should work on starting your assignment for the remainder of the block.